You're replicating your object data between two Nutanix object stores and life is good. Until suddenly you have an outage and need to fail over to the DR object store. What do? How does that even work? There are a number of things to consider, like addressing styles, server certificates, bucket policies, and client redirection. But don't worry, I'm going to shine a light on all of these in the next few minutes. Hey, I'm Steve from Nutanix Technical Marketing, and this is the latest video in our Nutanix Unified Storage Disaster Recovery series. In the demo you'll be seeing shortly, I'll walk through everything that needs to be configured when you're replicating between Nutanix object stores and want to be failover ready. To automate the process of failover, we recommend placing your primary and recovery object stores behind a global server load balancer, or GSLB. Now this should not be confused with the load balancers that come as an integral part of Nutanix objects. Those are really just local traffic managers discrete to a single object store, whereas GSLBs can work across multiple object stores, which is what we need here. I just want to make it clear also that Nutanix at this time doesn't build or supply GSLBs, but there are plenty out there to choose from. Alright, let's pay a visit to the lab. Here we are in the Objects Management page in Prism. We have two object stores. Think of O1 as primary and O2 as DR, and these are on different physical clusters. Diving into object store number 2 to begin with, our first task is to add FQDNs and SSL certificates. You can just ignore the FQDN that was deployed with the object store by default. That's there for internal purposes. So in fact, one of the first things you should do after deploying any Nutanix object store is apply the actual FQDN that represents your organization's domain. Because we're thinking about replication and failover here, we'll add not only this object store's FQDN, but the other object store's FQDN as well, 01. I'll explain why shortly. Next, we need to add a correct SSL certificate because, of course, we want our client server traffic to be safely encrypted. So we upload the key and corresponding public certificate right here and hit save. Now, why do we even need to perform this step? Well, in a DR situation, we need our DR object store to be able to respond to requests intended for the primary object store. And here's the issue. The client may be using virtual hosted style requests, which take the form bucket name dot and then the object store's FQDN. And if the DR object store is not configured with the FQDN specified in the request, it will reject the request. And we don't want that. Alright, the certificate has been added. We would of course need to take the same steps on object store 1 as well, but I did that earlier to save time. Now let's see what buckets we have. This is our destination bucket, Fire Bucket 1. And something we need to be sure to do in advance is set the correct permissions on the DR bucket. S3 users should have the same permissions as they have on the primary bucket. Now, permissions are not automatically copied across by the streaming replication process, so do be aware of that. And now we're switching over to our 01 primary object store. This also has a bucket called Fire Bucket 1, and we'll be writing data into that shortly. But first, let me clarify why I've given the same name to the source and destination buckets. It's simply so that client requests do not need to be modified in a DR scenario. If the source and destination buckets did have different names, you'd need something in the data path rewriting the URL for each request. That's achievable with, say, a global load balancer or reverse proxy, but hey, no need when the names are the same to begin with. Alright, next we need to make sure that replication is set up to the other Fire Bucket 1, the one on our DR object store. And there's the rule, already created. And we also have to have replication set up in the other direction coming from object store 2 here to object store 1. That's also in place. And that's because if we do failover, we'll want any new objects created at the DR site to be replicated back here to primary. I've opened a couple of terminal sessions here on the right of the screen. The top one is a traffic instance. In this demo, we're using traffic as a global load balancer across the two object stores. It's watching for outages, and if the primary fails, it'll redirect clients to the DR object store. The lower session is an S3 client. This will run a script that uploads files continuously to Firebucket in object store 1. If we look at the script, we can see it makes an encrypted connection and is using the virtual hosted style addressing we discussed earlier. In the lower plane of the client session, a monitoring script is issuing constant S3 lists of the bucket contents so we can see what's going on. And now let's kick off the writes. And the screen you're looking at now is Objects Browser showing the available buckets on Object Store 1. We look inside Firebucket and we can see the same view as our monitoring script. Then if we flip to a different instance of Objects Browser, this time looking at Object Store 2, we can see the contents of the DR bucket. Lo and behold, the same objects are there, and that's because the objects are getting replicated across the moment they're uploaded to the primary bucket. Alright, let's simulate a failure of the primary object store. We're doing that here by adding a firewall rule that blocks the connection between the global load balancer and the primary object store. List operations are now failing, client I/O is paused. For all intents and purposes, Object Store 1 is down. But traffic detects the failure and is now rerouting client requests to Object Store 2, so client I/O continues with no real interruption. Looking again at the objects browser that's pointing at Object Store 2, we can see objects continuing to be written to the bucket. And the bucket in Object Store 1 is now the replication target, so newly created objects are replicated to it from Object Store 2. Now we're going to remove the firewall rules so the client can once again connect to Object Store 1. Now the client I/O continues this time because Object Store 2 is still up and running, it's not a failure situation. Traffic detects that Object Store 1 is now available again and directs client traffic to it, and the file writes now continue directly to Object Store 1. Let's see that again, but this time with a real cluster outage. That's what you really want to see, isn't it? We're happily writing to the bucket in Object Store 1. Let's go to the server lights out management card. This is a single node NCI cluster that Objects is running on, so powering this node down will kill the cluster. Let's do it. The I/O stops. The load balancer detects the failure and reroutes traffic to the DR Object Store. The browser to Object Store 1 is no longer responsive because of course it's offline. But if we switch to the browser pointing in Object Store 2, we can see all our objects present and correct, with new objects being created there as well. And that's really all there is to a Nutanix objects failover. Once everything's in place, it's pretty much just a question of simple client redirection. I appreciate your time and attention, and if you get a moment, check out the other videos in our Nutanix Unified Storage Disaster Recovery series. Have a good one.